You are looking at the simplest of all circuits, the series circuit. It has a battery that provides the electrical field that causes the highly mobile electrons in the closed loop of wire to flow from the negative end of the battery to the positive. When the electrons enter the light bulbs, the high resistance filament converts the electrons' energy into heat and light. Every electrical circuit contains a voltage source, a closed loop of wire with a lot of mobile electrons, and something in the circuit that turns the electrical energy to some other form of energy. Let's go over it again. In order to create electrical current to power light bulbs or other electrical devices, we need a complete circuit, a voltage source that causes the electrons in the wire to move, and a conductor that has a lot of free electrons. Since metals usually contain a lot of free electrons, they are often used to make wires. The measure of the rate at which charge is flowing around a circuit is called current. There are two factors that determine the current in a loop of wire: voltage and resistance. If you increase the voltage in a circuit, all things being equal, you will increase the current or flow of electrons in the circuit. The other factors that determine the flow of electrons in a circuit is the amount of resistance the electrons experience as they move through the wire. The next video will reinforce some of the concepts you've just learned.
If an outside electric pressure or voltage is applied to a conductor, the electrons will move predominantly in one direction. The effect is that electrons move from the negative to the positive terminal. This is the electric current. The unit of electric current is the ampere. 1 amp, now hold on to your hat, 6,300,000,000,000,000,000 electrons passing any given point in 1 second. Current, or amperage, then is the number of electrons that pass a given point in a given time.
The symbol for current is the letter I, and current is the amount of charge passing by a single point in the circuit per unit time. The unit for current is coulombs per second, or amperes. Let's try a problem involving calculating current. You've got 10 coulombs of charge transferred through an electric circuit in 5 seconds. Then the current in this circuit is what? Well, I equals Q over T. So 10 coulombs divided by 5 seconds is 2 coulombs per second, or 2 amperes, also called amps. Here's where it gets a little tough. If the current problem you're working on mentions the number of electrons flowing in a wire, you must use an equation that is not on your reference table. Since the charge of an electron can be found by multiplying by 1.6 times 10 to the negative 19 coulombs, the original current equation changes into the one you see here. Here's an example of a problem that uses the new equation. We know this because it mentions the number of electrons in the circuit. A wire carries a current of 2 amperes. How many electrons pass a given point in the circuit in 1 second? Since I stands for current and T is time, this is what the equation looks like when we substitute the information into this new equation. When we cross multiply and divide, we get 1.3 times 10 to the 19th electrons. The rate at which charge is flowing around a circuit, it's called current. The current equation is I, current, equals Q, charge, over T. I equals Q over T. The units are amperes or amps, or coulombs per second. if you're given a problem where they're asking for or giving you the number of electrons, I equals the number of electrons times 1.6 times 10 to the negative 19th coulombs divided by T.